Okay, 6.4, today we're entering day 2, solving compound inequalities. Once again, a little trickier inequalities today for day 2. Okay, I think you had a problem like this on your assignment, and what we have is a 3-part inequality. It is an AND inequality, but we do not have the variable isolated. So we need to isolate. How will we go about isolating x, Johnny? From where?
From 7
and the -1, good. Okay, so what you do to one expression in this inequality, you must do to all expressions in the inequality. Use inverse operations to all 3 sides to undo what's going on with your variable. Good. So -1 minus 1 is? -2. Good. I heard a 0. Uh-oh. X is now beautifully alone. Don't forget the signs. These signs are different. 7 minus 1 is?
6.
Good. Should we have changed the signs?
No.
Why not, Ellie? Good. We're not dividing by a negative, we're not multiplying by negatives, so we don't. But will we see that today? Yes. So we will change every sign if we happen to be multiplying or dividing by a negative. Okay? So what does this look like on a graph? Is this opposite rays or is this a segment? 3, 2, 1.
Segment.
Say it louder. 3, 2, 1.
Segment.
It's a segment. So we just need these extremes visible, right? -2, -1, 0, 1, 2, 3, 4, 5, 6. And Matthew, what kind of graph do we have here? What does it look like?
For -2, you do an open dot, and for 6, you do a closed dot, and then you connect them.
We call that the intersection of the solution sets, right? Intersection. Okay, so the other type of compound inequality, our OR. We're basically reviewing what we've already done because we don't have 3 parts, do we? So today's objective really is what we just did over here, right? It's you got to treat all 3 sides the same in this type of an AND inequality, but in this one, we just simplified the inequality the way that we were doing yesterday. Undo the operations and reverse PEMDAS order. And then graph. Okay, Sabrina, tell us how to do that. Here. Let's start with the left one. What are you going to do first? If I add 11, am I getting x isolated? Good. We're going to add 2. What do you have left?
3x is less than -9.
Does that change our sign? No. So we have... Good. And this one here. Second one. Good.
2x is greater than 8 and minus 2.
So we had no sign changes. And graph it. We want to see -3. We want to see 4. So -3. How does this look on the graph? Cassandra, how does this look?
You put a closed dot on -3.
Closed dot on -3.
And then you have the arrow going to the left.
The left. Less than. X's are less than -3. Okay? And then the other?
And then you put an open dot on the 4 and have the arrows go.
Very good. X's may also be greater than 4. Okay, so we're just going to practice a few more together. And if you are watching this on video, pause, do your best, come back, check your answers, and we will see you back when you're ready. Okay, if you need to, you might want to pause the video to look at this, but in the first example, adding 5 to all sides gives us our inequality, which ends up having open circles on the endpoints and a segment. In example 5, we added a -4, or we subtracted 4 from all sides, and then divided by 2, giving us a 3-part inequality with solid endpoints and a segment between them, right? And then in the last trickiest one, we had to divide all sides by -1 because the z was negative. That was after, of course, we added 1 to all sides, right? And that changed the signs, So rather than leaving this inequality in order from greatest to least, we turned it around and put the least value, the least expression on the left, which gives us what we commonly find with our 3-part inequalities, least to greatest, and the signs are both less than signs, right? It still gives us z values that are greater than -4 and z values that are less than 6. In this case, we have our open endpoints again. So very good. Okay, and you know what? I think you're ready for your assignment. That's enough, right? 6 minutes and 30 seconds, world record. Okay, good luck.